Hello everyone, and welcome to Lesson 7.1, Ratios and Proportions. Now these are things we've talked about before, so pause this video and see if you can write down everything you can remember about what a ratio is, and the 3 different ways that you can write it. Then also try and write down what a proportion is and how to solve it. So that's going to go on a Google Doc that you're going to submit to me just so I can see what you remembered before this lesson began. Okay, then start this video up again to see what the book actually has to say about that. Okay, so what is a ratio actually? Well, the definition is that it's a comparison of 2 numbers by division. So basically any fraction is a ratio. Okay, and there are 3 different ways to write ratios. You can write it as A with a colon and then B. So this would be A to B. And you could write it with the word A to B, or you can write it as a fraction, A over B. Those are the 3 ways to write ratios. Let's take a look at one of the most common types of ratios, slope. Okay, so here we have example 1. They want you to write a ratio expressing the slope of line L. So you'll notice in the picture this red line is line L. They've given you point A, which is -2, -1. They've given you point B, which is 4, 3. So pause this video, see if you can find the slope, and then check your answer on here. Okay, so you may remember that slope is the ratio of rise to run. So it's rise over run. This is the actual slope formula, y2 minus y1 over x2 minus x1. And here I just put in the numbers, and I got a slope of 4/6, which reduces to 2/3. So you have a check it out question coming up next. Check it out question number 1 asks you to find the slope for a line M given 2 points. And they gave you that C is -2, 3 and D is 6, 5. They want you to write a ratio expressing the slope. So pause this video and do that, and then come back for example 2. Okay, so example 2 gets a little more complicated. What they've done is they've given you a ratio that has been reduced. And not only is it a ratio that has been reduced, but they have several numbers in their ratio. And that's okay, they can do that. But we need to figure out what this ratio was before it was reduced, and then apply that to something else. So it says the ratio of the side lengths of a quadrilateral is 2 to 3 to 5 to 7. And its perimeter is 85 feet. What is the length of the longest side? Okay, so the first thing we need to do is take this ratio and figure out what these lengths could be and what they reduced by. So notice that they've given us a perimeter. Now a perimeter is all of the side lengths added together. Okay, so they've added all of these together, but remember these were multiplied by a number, and it's going to equal 85 feet. Okay, now because these were all reduced by the same number, I'm just going to use a variable to represent that. So let's take a look at some of the work. Okay, so what I did is I said that the ratio was reduced by an unknown factor. So I used x to represent that factor. So I said the sides are going to be 2 times x, 3 times x, 5 times x, and 7 times x. Now, we know that to get perimeter, we had to add these. So I made an equation that says 2x plus 3x plus 5x plus 7x equals 85. Now let's see how to solve that equation. Okay, so we're solving it. So I just combined my like terms, and I still have it equal to 85. And then I just divided by 17, so x is 5. Now, I'm not actually done there because they wanted the length of the longest side. So I took the number that was the biggest, the 7, and I have to multiply it by that x. So I did 7 times 5 is 35 feet. So that's how you do those questions. Now, they won't always give you perimeter. Sometimes they'll ask you about other things that are true about geometric shapes, but we've practiced a lot with them, so just think about what you know about each type of shape. So you have a check it out question coming next, so get that Google Doc ready. Okay, so check it out question number 2 says the ratios of the angle measures in a right triangle is 1 to 6 to 13. And they want to know the measure of each angle. So think through what you know about the measures of a triangle and what their total would be. Okay, so the angle measures in a triangle. Think about that. Pause this video, see if you can figure it out, and then come back for the next half of our lesson. So earlier I asked you to write out what you thought the definition of a proportion would be. So the actual definition is that it's an equation stating that two ratios are equal. So that's going to take two ratios, and they could be with the colons in between, they could be fractions. It's just going to say that they're equal. Now there are two terms that we have for the parts of these ratios. Those two terms are means and extremes. So you'll notice if I write it out using the colons, the extremes are going to be the first number and the last number, and the means are going to be the two middle numbers. Okay, if I was to write it out using fractions, the extremes are going to be the first number on top and the bottom number on the right side, and the means are going to be these two blue numbers, the one on the bottom in the first fraction and the one on the top in the second fraction. And you'll notice that when we're solving it, they're the ones that create our cross product. If I was to solve this, I would do A times D is going to equal B times C. So let's see some examples of how to solve these. Okay, so in example 3, they ask you to solve different types of proportions. Now the first example is the easy example. This is one that we've seen before in pre-algebra. All we have to do is find the cross product of this and finish solving for y. So pause this video, see if you can find a value for y, and then come back to see if you're right. Then we'll talk about some more difficult examples. Okay, so we needed to use a cross product to solve this. I did 5 times 63, and it's going to equal y times 45. So here's my cross product. I did 5 times 63 is 315, and then I divided by 45 to get y alone. So y is 7. Let's take a look at another example. These examples are going to use some of the algebra you learned in Algebra 1. Okay, so in this one, they asked you to solve this proportion, 50 over y equals y over 2. Now, I left the work up here so you could see what would happen. We're going to still use a cross product. So I did 50 times 2 is going to equal y times y. Now, when you multiply two variables together, you add their exponents. So it's y to the first power times y to the first power is y to the second power. Okay, and 50 times 2 is 100. So what I did to solve this is I did a square root on both sides. So the square root of 100 is going to equal y. And notice when I introduce the square root, I need this plus or minus sign. And the square root of 100 is 10. So y is plus or minus 10. Let's take a look at another difficult example. Okay, in this one, they want you to solve this proportion. X plus 2 over 6 equals 24 over x plus 2. Now we're going to be using the same strategy we've been using all along, a cross product. But notice what happens. I have x plus 2 times x plus 2 is x plus 2 squared. And notice I didn't actually multiply this out. That's because it's actually much easier to solve if you don't. Okay, then it's equal to 6 times 24, which is 144. Okay, now what I did is I did the square root on both sides. And when I do the square root, I have to put this plus or minus sign because I'm not sure which one it was. Okay, so I have x plus 2 equals plus or minus 12. Now what I'm going to do is I actually have to divide it up to see the positive version of 12 and the negative version of 12. So I separate it into two equations. X plus 2 equals 12. And x plus 2 equals negative 12. And then I solve each of these separately, and I get two different answers. When I add 2 on both sides here, I get 10. When I add 2 on both sides here, I get negative 14. Let's take a look at one last example. Okay, so in this example, they ask you to solve the proportion x plus 3 over 3 equals 9 over x minus 3. I'm still going to use a cross product, but I have to watch my algebra. Notice these are almost exactly the same, except this has a plus and this has a minus. So I can't do the same thing I did in the last example, where it was something squared. I actually have to multiply this out. Now, you may recognize this pattern as a difference of two squares, and when you multiply that out, you just square the first term, so it's x squared. You write a minus sign in between, and then you square the last term. 3 squared is 9. Okay, if you wanted to, you could use FOIL or the distributive property to actually multiply it out, but this is the answer you would get. Now I would have to do 3 times 9 for the other side. I'll just add 9 to both sides, and then I do a square root to get positive or negative 6. And this plus or minus sign needs to be there because you're the one that introduced the square root. So now it's your turn. We have another check it out question. Okay, so check it out number 3 gives you 4 practice problems to do. Okay, so you're going to solve each proportion. So this is the end of this video, and there's going to be another video with example 4 and 5. So work these out on your Google Doc and then tune in to the next video. I'll see you soon.